Hey everybody, this is Larry. This is day 17 of the Leetcode Daily December Challenge. Hit the like button, subscribe, and join me in Discord. Let me know what you think about today's problem. Today's problem is Maximal Square, a problem that I've seen a few times in my life. I think the first time I've seen it was a long time ago. And I thought it was pretty hard, to be honest. It is one of those things that just by repetition, it's been or like these kind of problems have come up a few times, and I think after you've done a similar problem the first or maybe the second time, you do get the idea about these concepts a little bit. But that said, it's way ad hoc-y. I mean, yeah, the solution is dynamic programming, but if you haven't seen it before, I think it's hard to kind of come up with. But at least but that said, yeah, I mean, I think another way that I could, so there is the dynamic programming one, which we'll go over in a sec. But I think another kind of interesting way, perhaps, is actually using prefix sum and then binary search. I think that's also an idea that is not as optimal per se as the dynamic programming, but also an idea that you can play around with if you somehow, I don't know. I mean, I think that idea is also way better, yeah, or not way better, but like it's something that you can come up with without like a lot of I don't know ad hoc-y type of coming up with this thing. But I've done this a couple of times, enough times. Like the first time I'm talking about, like before Leetcode, before all these other things on other judges. And I think I probably did it in top coder maybe like 10, 15, no, not more than 10 now, but let's say 15 years ago or so, maybe more actually. So this is definitely something that like I mean, it's something that it's just an idea, right? And with the idea, it's the observation, and the observation allows you to kind of solve it even without necessarily like memorizing it. Like I don't memorize these things, but okay. So the way that I would think about this one is, let me try to bring up the drawing thing. Give me so then, yeah, the idea here is dynamic programming is the one that I'm going to go with. And the idea here, you can play around with the binary search. I think that one, I'm not going to go over it, but it's come up about much easier if you ask me. But the idea here is that, okay, so and I probably have a good enough video on this in the past, but the idea is that, okay, for each square, or each cell rather, for each cell you try to figure out what is the biggest square that is in the cell, right? And then so you start with 1, and let's say you have this thing. Let me actually use a thicker color, a thicker brush. So let's say you have this thing, and then the idea is that if you have 3 of these of the same shape or same size, or at least if you have 3 of these of a size, then you could combine them. You could just check to see whether let me draw this a little bit differently actually. Let's say you have this, let's just pretend this is a 1 for now, and you have these 3 corners, and if this is a 1, then if this is a 1, then you could complete the square, right? So that's basically the idea. And of course you can kind of just by visualization and induction, you could figure it out by a 2 by 2 one. Like for example, these are 2 by 2s, and then if this is a 1, then you're able to construct a 3 by 3. And of course you can prove to yourself very quickly that this is the case. Maybe it's a little bit trickier with respect to, okay, what if they're variable size, right? Well, let's say this is size 2. Let's say this is size, I'm just looking at from this corner. Let's say this is a 2, so you have a size 2. Let's say you have, I don't know, let's say you have this is a 1, right? And you can draw cases to kind of support your ideas and just like explore it out a little bit. But let's say you have these 3. Well, then in that case, this 1 means that this thing is not a well, at least like if there's if this is a 1, it's not a square of size 2, right? So that means that there's something wrong here. That means that you cannot have a thing of size 2. So then you take these 2, 1, 1, and then you just draw a bit new square for those, right? And of course, the other way is also easier. Maybe if this was a 3, then you can just draw a 3 thing, and it's still going to be blocked by the 2 because you cannot draw a 4 here, because that means that, let me change the color a little bit, because there's some like induction thing of that, like that means that because maybe another way of phrasing it is that in order to have a square of 4 by 4, you need a square of 3 by 3 and a 2 by 2 and a 1 by 1 at least, and this, and you can kind of do like think about it recursively, but that's just not the thing that happens unless all the things are in the right place. So yeah, so with that said, let's start with dynamic programming, and let's get started. So we're just setting up the thing, and then let's just call it DP for or let's say maximal square, say is equal to 0 times and this is just an R by C max matrix, and in this case, of course, we'll do just oops. I could do I. Sometimes I do I. Sometimes I do X, Y. I don't know. I, J. It doesn't really matter. But yeah. But yeah. So then here is equal to the minimal. Actually, and okay. Let me actually set this up a little bit better. Let's set up the default base case is equal to matrix of IJ, right? So then now, if I is greater than 1 and j is greater than 1, of course this, we have to combine from, like, if you're on a border, at least on the top or left border, you can redo it. So you need this constraint, then maximal square of ij. And here you can actually do maybe like n maximal square of ij is at least 1. Though, I mean, in this case, it can only be 1 or 0, but why not write it this way? And then this is equal to the minimal of those 3 spots, the corners that we talked about. Plus 1, right? Yeah. Wait, yeah. Because now you're trying to extend that, right? And then now, I mean, you could do another loop. You can just have a best variable, and that this can only happen. I guess technically it's not only here. It can only happen afterwards. So let's just do it here. Yeah, and that's pretty much it, really. And yeah, so this is going to be. Ooh, what did I click on? I think I clicked on. Oh, contribute instead of counter. Whoops. So this is going to be linear time in the size of the input, which is R times C. At least it would be if I did it correctly. Is the input in a weird way? Oh, the input is an int, so we just have to fix that. Whoops, didn't actually notice that. But yeah, this is going to be R times C. Oh, well, yikes. Did I mess up something? Oh, dong. What did I do wrong? Oh, return to area. Okay, so that's my bad. I just misread. Oh, I didn't. I've been doing that a lot lately, where I misread. I didn't misread, but it's kind of sad because there's only like 10 words in this sentence. I missed it. But this gives us the square of the maximal. When I say size, I meant the length of one of the sides. But of course, the maximal actual square is going to be, or the area of it is going to be just the best of the length square, right? So yeah. So this looks good. Let's give it a submit. Got some runtime wrong answers in the past, so hopefully this one I'm good. This time I'm good, so I am happy. Yeah. You can probably save some time if you only do like change this up a little bit. But yeah, so this is gonna be a linear time, linear space, where linear is the size of the input, which is R times C, right? So yeah. I mean, yeah. So that's gonna be optimal. As a lower bound, of course, someone is always going to point out that you can do it in constant space, which is technically true. What people would mean to say is one extra space, but I don't really consider those as one space because you're manipulating existing memory. And of course, anyone, I don't know, as an API, I don't think that if I pass in a if I pass in a matrix of rows and suddenly my matrix is gone, I don't think that I consider that all one space, but to each their own. So definitely, do your own research or whatever there, or like just make sure you analyze it quite okay. But that's pretty much all I have. Linear time, linear space, that's what I have. I'm gonna see what I got wrong last time. Huh. So this looks exactly okay, except for I forgot to. So that time I start from the zeros. Why did I? Where did I go out of bounds actually? Oh, and I did ASCII art back then. Huh, I am curious. Dun dun dun. Do I just have a typo? Oh, because this is rows in +1, and then now this is just going to rows. That's a silly off by 1. Silly Larry. Did I fix that? I guess so. No idea, actually. I mean, I clearly fixed it, but I don't know what I did. I'm just curious, looking back. And I did it twice, actually. That's a little bit curious. What is the difference here? Oh, the difference here is that I just... No, that's not right? Wait. I mean, I did add an if statement, but that's not it. Line 4? But I didn't handle it today, did I? Huh. Did they just took out some input? Is that why? I wonder if I complained last time. Because, well, I mean, that's not a possible input, but I guess in the passive was? What? Huh? But that's not, this is a 2x2, right? So why is this? Man, I am so confused, to be honest. What happened last time? And this is also the first. Oh, it's the second input. What is going on? Line 4? Is this line 4, right? Huh. I don't know. I don't know what's up here, to be honest. But it seems like it used to have an input that is possibly no rows. But then it puts a weird one. So I don't know why that is. Maybe they just changed the inputs, and then if you ask me, my guess is that they actually changed the test cases by removing an invalid test case. And what happened is that they store these, which makes sense, to be honest, conceptually. They store the index of the test case that is wrong, but because they removed it, it just got shifted everything by 1, and then it happens to be the actual next, like the test case after that, which is actually good. But that's my guess. So I guess they fixed it in the past. I mean, I probably have a video, so we can kind of check that out. But I was just curious, like what I did wrong last time. So because I'm always trying to learn even from past mistakes. But I guess in this case, I just kind of. But you can also see that my code was much bigger back then as in Java as well. But so the code got a little bit tighter. But and oh yeah, min of 3 things. What? Yeah. What did I get wrong answer here? I just have a bad default case because I don't check. Oh yeah, so this is the thing that I was actually almost doing today, where that's why I took this loop or this thing outside the if statement because of this case. So I guess I am improving in that. Okay, I mean this is a pretty straightforward video now. So because I've done it like apparently even on Leetcode I've done it. I guess 3 times. That time I submitted twice. So yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. I'll see you later. Stay good, stay healthy, take your mental health. Bye bye.